Hello everyone, welcome to another con session. This glorious day we'll talk about remainders. Remainders is what is left when you divide one number by another. So let's say you have a number like 43 and you're dividing by 7. In this case, you will get a quotient of 6 because 6 into 7 is 42 and a remainder of 1. So when you divide by 7, your remainder can be 0 when the number is divisible by 7 or 1, 2 till 6, right? So if you divide by n, for example, the remainder will lie between 0 to n minus 1. Great. So we have a basic sense of remainders. Let's see the kind of CAT questions you can see. There are three major categories. You can get questions based on powers, right? Or find the remainder of some product with respect to another number, or remainder problems that involve HCF LCM. The last two categories we will see when we look at questions. Before we start looking at questions of powers, I just want us to be comfortable with the binomial theorem. The binomial theorem is the expansion of A plus B, right, raised to n. So let's simplify this whole thing. When you expand this, you will get n plus 1 terms. The first term will be A raised to n. The last term will be B raised to n. And in between, your powers of A will reduce and powers of B will increase. So second term will be A raised to n minus 1 into B raised to 1, right? Third term will be A raised to n minus 2 and B square, so on, right? The term just before B raised to n will be A raised to 1 into B raised to n minus 1. Now these terms will also have constants. So think of the constant as n c, right, to the number that is the power of b. So here the power of b is 0, so nc 0. Here the power of b is 1, so nc1. Right, here the power of b is 2, so nc2. Right till the end where you'll have power of b as n, so ncn. Of course, you will have plus or minus depending on whether it is a plus b or a minus b. If it is a minus b, odd powers of b will have a negative sign and even powers of b will have a positive sign, right? So this will become negative, but this will remain positive. Great. So let's do a simple question to understand how these things work. Let's say I want to find the remainder of 3 raised to 72 with respect to 8. So what we'll always do in such cases is we'll try and find a power of 3 that is close to a multiple of 8. It need not be close to 8. It can just be close to any multiple of 8. So here this is easy. A power of 3, which is 3 square, right, 9, is very close to 8, and we'll always try and get a difference of 1. So I can write this as 3 square, the whole raised to 36, which is the same as 9 raised to 36, right, which we can rewrite as 8 plus 1. Raised to 36. Now let's use the binomial theorem here. When you expand this whole thing, every term will have 8, right? The way every term here has a, every term in this expansion will have 8 except the last term. So we are only concerned about the last term. The last term is going to be 36C36 NCN, right? Which is always going to be 1. So that's not a concern, right? This is 1, so we can forget about it. And b raised to n, which is 1 raised to 36. So that's it. The answer is just going to be 1 raised to something which is going to be 1. Right? Great. Let's apply this in slightly more complicated case. I'll see you when we do questions.